can see it.
Thanks. So what we'll do is let me present to the meeting. And I hope you have followed up this installation instructions. Just very quick update on the installation instructions is there are 2-3 ways I have mentioned it here. So let me just go through this anyway. So simplest way is Docker desktop. So install using Docker desktop, but some companies don't allow Docker desktop because Docker desktop has been made commercial. Docker is still free. Docker desktop has been made commercial for some companies with certain turnover or a certain number of employees or more. So if your company is falling under that category, then don't install Docker desktop. Incidentally, the company where I work in, they have told us not to use Docker desktop because of these restrictions. But there are some company, and you would have gotten an email if your company does not allow that. But if your company allows it, then and you are using company desktop, company's laptop, then feel free to install Docker desktop. That's the easiest one. Additionally, if you are using your personal laptop, then also you should install Docker desktop. This very less setup you need to do. There is another one, Docker CLI with Minikube. Will be using Docker machine and Docker CLI. That's what I will be using, but the commands are also same except the start command, which I will be starting Docker using Docker machine. If you're using Docker desktop, you don't have to worry about that. It'll automatically start it for you. But I will showcase this using Docker machine, how to start and everything, so that if you are using option 2, you can use that. Option 3, I will not be going through this. I have experimented it and documented it works. So if you want to use Podman with Minikube, you go ahead with that. Docker desktop has everything installed, Docker and Kubernetes. But if you are not using Docker desktop, you have to install Docker separately and Kubernetes engine, which is Minikube, separately. So that's option 2. And option 3 is instead of Docker CLI, you could use Podman. So the only difference between Podman and Docker is, you replace Docker command with Podman, everything works. Or you can alternately set an alias Podman as Docker. So you can run Docker command internally running Podman command. Everything else is same. So just follow these instructions, and hopefully most of you have already done it. So what I'm going to do now is we are going to cover the basics of Docker, and it's very simple. We'll not be going into details of Docker. The Docker itself is a huge things. So we'll covering only those aspects which we'll need for Kubernetes, and as you go along, you will be discovering many things yourself. So first of all, what is Docker? So all this Docker and Kubernetes is containerization. And right now, let's just focus on Docker. Once we cover Docker, then I will explain you how Docker and Kubernetes are related, or any container engine like Docker, how that is related to Kubernetes, how Kubernetes uses Docker image and things like this. I have a diagram for that. I will explain you. But for time being, let's focus only on the Docker. So Docker is an a container engine. So it's open platform for, and why do we need it? What and why? It's an open platform to developing, shipping, and running applications. So very brief summary of this is, our traditional model of development and deployment is that we write our code on the local laptop, and we do unit testing, and then we push the code into the GitHub. And after that, our Jenkins jobs, if it is the proper CI/CD setup, Jenkins jobs take it. Assume our local laptop is in our local development environment is Windows or Mac. Then the CI/CD job will take it and publish it to the QA environment, for example, or dev environment first, depending upon how your CI/CD flow is. Generally, it goes to dev environment. Your dev integration test cases get done, and after that, it goes to QA environment. QA integration test cases get run, and then it goes to canary and production. Now, one of the problems you would have seen is that people say it works on my laptop, but why it does not work in QA, or why it does not work in production? And the problem is that the main such problems come because the environments are different. Your laptop is your local dev environment could be Mac, but your QA environment could be CentOS. Your dev environment could be CentOS or Ubuntu or things like this. There's mismatch in the environment. The configurations, the setup are different, and that is what Docker tries to remove. You could have every development in your Dockerized environment, push it, then only the Docker image will keep getting created. Test it out, create a Docker image, test with Docker image, everything works fine. Then you push the Docker image, and that Docker image will be taken by the CI/CD process. And what that Docker image is, how does that solve, we'll go over this. But Docker images basically contains all the dependencies and your code together, so that there's no problem in the environments. Whatever you have tested in your dev or in your local, same will be tested in the queue, and same will get deployed in production. So those problems won't come. And that brings the second point. This way your delivery will be fast and consistent, because there will not be environmental difference, and it will be responsive deployment and scaling. So scaling will go into the Kubernetes and see how to scale it up. Docker also has Docker Compose. See, with Docker you can set up, you can have only one instance of your application running, but you have orchestration engine like Kubernetes or Docker Compose. There is one more I'm forgetting. Docker Compose, we will not be using it, but it is also is an orchestration engine which can scale up your application. We'll be focusing more on the Kubernetes, but Docker Compose is an alternative. Some people do use Docker Compose as well. Running more workloads on the same environment. Docker Swarm, Anshul, Docker Swarm was another one. Running more workloads on the same hardware. I will show in the diagram. You can have one hardware where you can have multiple Docker containers running, so you can optimize your hardware as well. This is a diagram. This is how virtual machines used to work. I don't know how many of you know virtual machines. Earlier, there was virtual machines are very popular. You could they tried to follow the similar pattern, that you use virtual machines to deploy your applications and then take that along in different environments. But it's heavyweight. Virtual machines are heavy. So take this example: you have a physical machine, over that you have host MS. Then you have some virtual machine, hypervisor, which deals with virtual machine, creating the virtual machines and all those things. And then you have guest OS. And then over this guest OS, you have their own, each guest OS its own library. Then application is deployed over this. A VMware, so VirtualBox is one, on your local laptop. If you ever dealt with virtual machines, you would have installed a virtual machine using VirtualBox or VMware Player. It has free version also, VMware Player. So you would have used one of these, and you would have realized yourself that it's pretty heavy. If you ever use any of these, you have to open VirtualBox or VMware Player, start the machine. It will ask how much memory you want to give, minimum 8 GB to 12 GB, or that much memory you give to that. It's as good as a different operating system running on your machine. So one is your laptop or host operating system, and second is VM operating system running. And it used to be pretty heavy. That's, I'm talking about your local setup. But in production, this is how the environment would look like. You compare this with container. So in container, you have server and you have host OS, which is here also, and then you have Docker engine, and that's it. You don't have guest OS and many these are the heavy heavy things you don't need. And then you have your application deployed inside the containers. We will also deploy application inside the container, but this is how it works in production. And there are you can share the main libraries, some binaries and everything you can share across. For example, this application A needs the same binary, application B needs the same binary, so this can be shared. So that's why container is very lightweight. And if you ever use Docker, or I'm sure you must be using it, compared to VMs, the load on your system by Docker images is pretty less. Now, having said it, if you have so many Docker images running on your local laptop or any server, that will also slow it down. So it's not that it's a magic bullet, but compared to the VMs, it's pretty lightweight. Now, how Dockers work? So I will go through the theoretical part. Then I have a practical example of this. I will go through that. So let's say you are trying to create a, you start from scratch, correct? And when you start from scratch, you are writing a code, and that code you want to be published as part of a new image which you will create. And we will do that as part of these sessions. So first thing you do is, as part of your code base, you create a Docker file. Now Docker file, what is Docker file? It's a text file only. It's a text document containing all commands a user could call on the command line to assemble an image. Basically, all you will do is that what your image will have, what are the things in your which your Docker image will have. You mention all of that in the Docker file, and we'll see example of that. There's a reference of this. You can see the reference of this. I've given some example. Once you have a Docker file, you write your code, you have Docker file, and now you want to create an image. That to create an image, you use Docker build command. And to use Docker build command, I have the instructions how to use that. Basically, Docker build command will read the instructions in the Docker file sequentially one after another, and it will create a Docker image. Now your Docker image is created. Now what you do of the Docker image, generally, if you are doing some experimentation or something, then you can keep the Docker image on your local environment itself. But generally in companies, they have their own Docker repository. All big companies will have their own Docker repository. JFrog is one tool, one of the many tools which companies use to host their Docker images. JFrog is used to host many other things also, like your Maven jars and all those things, but it can be used to host your Docker images as well. Some companies have subscriptions to hubdoc.docker.com, wherein you can pay some amount and you can have your private repository. They have a limit, like if you pay this much, then these many private repositories and these many users are licensed or things like this. So either way, or if you don't have anything on hub.docker.com, then I think they allow you up to I don't remember the exact number, but I think 4 or 5 private repository they allow, and after that it has to be public only. Public means anyone can access, and I'll show you how that all works. So and now we'll go over the Docker file. So how Docker file looks like, and I have an example of this. I will be explaining a few of the things, and then what Docker file we are using. We'll go over this, but I will not be able to cover each and everything of the each and every directory of Docker file. So I have given you a link which has every command of Docker file. You can go through that, and you can reference that if you forget something, or if you're trying to do something which I will not be covering. So you can always refer that. The first instruction in your Docker file is this hash syntax docker/dockerfile :1. So basically, it tells Docker which password to use. And if this at least when I wrote this was the latest one, and it's a comment. You can see it's a comment. It's just an instruction to your Docker engine. Now every Docker file will have a from command, and what this from command is, basically you are telling you build this Docker file over this image. Now what is this image? Some image would have already been created. For example, if you don't want anything, base images, if you want to work on CentOS or Ubuntu or things like this, or Alpine is the Linux flavor, which is pretty lightweight. So you can say from CentOS. So it will take the CentOS raw image. Where will it take it from? If you don't do anything, then it will try to directly connect to hub.docker.com, and will try to put the CentOS image from here. Whatever image name you have given, it will try to pull that image from there. If you have your own internal repository in the company, so generally, if you are working on your local environment, so and you want to test it out, so on your command line you say docker login and give your URL of the company repository, and then it will ask you the username and password on the command line. You can give that. In the CI/CD, the CI/CD setup is by default configured in companies to connect to their own repository, so that they can pull these images which is given from in this from command, and whatever image you will produce as part of your your code base, it will CI/CDs will be pushing into that custom repository itself. So from is the base image name, and it should be there in the repository. And I will open the hub.docker.com. I will show you a few of those, there. Work directory, it creates a working directory on your Docker image. And I will show you the example of that as well. And once you create work directory on the Docker image, it will use this directory for subsequent commands. So anything you do after this will be, the Docker will assume that it's as good as you have used cd/app. Here I'm giving /app, right? Work directory /app. So it's as good as cd/app, and every other command will be under this. For example, next command is copy from to. So it copies directly from your local system to the container. Now where will it copy? So let's say on your local system you are in folder, and in that folder you have a file ABC. So you're copying ABC to some folder, to some other folder. If you don't give, if you just give normal path, let's say copy ABC, then let's say T1. So it will assume that there will be a folder called T1 under app. So it will copy it there. So here the path is, and I'll show you an example of this. So if you don't understand now, you will understand with the help of example. So path is relative to wherever dockerFile is, right? So this path is relative from, and you can give // or /something. So you can do all of that. Run, it runs a new command. It runs on the top of new layer of current image. So it has two, so run has two forms. It's a shell command. The command is running a shell, which by default is bin/sh-c on Linux. Or you can run using, you can pass an array of parameters. So generally in array of parameters, you pass an executable, whether it is .sh file or some executable file, and the parameter it takes. It does not invoke a command shell. Here you are invoking a command shell, separate command shell. It runs in, this command runs inside this, but here it does not invoke a command shell. It normal shell processing does not happen. So for example, if you are running, say, run echo home, it will not do variable substitution on home. It will just try to run as is. So I will see some example of that. I have used this run, in one of our, we have used this flavor of run command in the dockerFile, and you will see example of that. I'm running my application using this run command. So run is one command. Command is command to run when image is executed inside the container. So so there's a difference. So run on top of a new layer on the current image, and command is command to run when image is executed inside a container. And I think I have used one command example also. We'll see. Docker build is the command which we use to build a Docker image, and it will build a Docker image from the dockerFile. And we optionally use tag parameter. Then but why do we need tag parameter? We want to be able to specify certain tag, certain version, for example, to the image we are building. If you don't pass a tag parameter, if you don't pass this, then it will, if you don't pass even tag itself, then it will be defaulted to latest. So now let me stop it here. We'll go to the example now, and this is the example I have. This is the example. By the way, I hope you have checked out the Spring Boot application on GitHub. It's mentioned in the setup guide, in the instructions thing. So we'll be using this application. So what we are going to do now is we'll go over this, and then I will we'll create a Docker image, and then we'll stop it there. So as we mentioned, the first line is syntax dockerFile :1, and I'm using this base image, adopt OpenJDK 16. So let's see what this image is about, right? Because I will be using normal Docker, not my company's repository. So this image should exist on the hub.docker.com. So let's try and see that. So if I go here, sorry, let me go here and say, let me close this hub.docker.com. And I search for this. So you see, this is an image. So I click on this. And if you want to use it outside your, you don't want to use in dockerFile, you just want to install it to command line, you can always use this. But this is the image, and there are various builds of this. So you can click on, for example, the build, and it will show you how this image got built. This is a dockerFile of this image itself, right? So we are using this image in our dockerFile, but this image will also would have been created using some dockerFile. And that Docker file of this image is here. So you can go through this. It has used Alpine, which is again the base image, one of the Linux flavor. And it has used all the instructions. Like I think it has installed Java and it's set up Java 16 is installed, and it has some Java home and everything. So for us, everything is ready-made. We don't have to do any of this, which it does, setting up Java and everything. We get it out of the box. And whatever new things we want to install over this, we can put that in the Docker file. So now, and this Docker file is in the, I have created that under tips_Java folder. This is the sample application we'll be using to deploy and everything. So what I do is, we discussed about the work directory. On the container, it will create a work directory called /app. Then it will create .mvn files, because it's Spring Boot, it will have .mvn folder. So I'm making it copy .mvn folder into .mvn. Now where this .mvn will go? This .mvn will go under this /app folder itself. So you will have /app/.mvn. Then I'm copying mvnw folder. So there's an mvnw folder also. This .mvn and mvnw folder I'm copying because Spring Boot needs it to start. And I will show you, this is how I use run command to start this. So I copied this mvnw folder also. This also goes under a /app folder, pom.xml, which is, if you worked on Maven, there's a pom.xml which which Maven needs. So that will also go go under this /app. And whatever else we have, whatever else I have, dot, and then I copy that as well. I copy source, and this is this is the source file which I have. This is source folder which contains all my Java code. You don't have to know Java, or you don't have to know Spring Boot. Just understand this is source folder gets copied under source. Source dot means the existing directory, which is /app, and under source folder it will get copied. There's a conf dir I have here. So this, and what is the purpose of this conf dir, I will explain in subsequent, when we reach Kubernetes. But right now, consider this is a folder, and I'm copying this folder into conf dir folder under app folder. There's a readme.md. I'm copying that also under the current folder, which is app folder. And only thing which I do is I echo, this is a command which I run. So if you see, there are multiple, run commands I have. You can have only one command here. If you have multiple commands, then only last command will be taken, but you can have multiple run commands. So I echo it, I want to see what is under, app folder, and it prints that. Now after app folder, now I'm changing my work directory to etc folder. And once I'm in etc folder, I'm making a directory here. I'm saying run make directory. So I'm creating a new subdirectory called conf dir. Why I need to do all of this? When we reach Kubernetes, there are certain things which I was trying, and you will see in the sessions when we reach Kubernetes session. Only for those I needed this conf directory under etc folder. It has not bearing on the Docker, on running the application itself. So you take this exercise as if you take these commands to learn what run command can do. So I created a directory called conf directory. And then I copy this conf directory on my current, which is this, into the etc conf directory, because here under etc I created this conf directory just now. Then I run one command and say echo, show me what is inside etc conf dir, and I run this. This is just experimentation. I just wanted to experiment and see what all the things I can do in the Docker file. Then I again run the echo command and I say cat this file. So there's even tips controller. If you go to source, you need to worry about only two files under into this. One is tips controller and another is the application, and I will walk you over what controller does. You don't have to know Java, you don't have to know Spring Boot, because I have written it for you. Basically it exposes some REST endpoint, and I'll show you what it does. But to complete this, I just cat this Java file. There's no specific reason to do it. I just wanted to play around and see what all I can do. Then after this, I go back to the app folder again. Now what I do is I run this mvn dependency go offline. This is a Spring Boot specific command. Only thing you need to learn is, because I am using Spring Boot, I am using certain external dependencies, and those dependencies I have specified in pom.xml. So if you go to pom.xml here, So these are the dependency which I'm using. So what I do is I tell dockerFile that whatever dependency, you can go to the documentation of the Spring Boot command. It has nothing to do with Docker as such. It's more of a Spring Boot command, but in short, what I'm trying to do is all the dependencies which I have, I will be, download that dependency, sort of club this together, because I'll be running this application in the offline mode, which means I will not be connecting to internet. These dependencies are getting downloaded from internet. So download it once, run this command, and then, and then run this application in the offline mode. So this is a run command. And then after this is done, I run this command, and this is where I run. I say, I run this application, Spring Boot run. And once I run this Spring Boot run, because the dependencies have already been downloaded and made available to run in the offline mode, my Spring Boot application will run fine. So what we are going to do now is we are going to see the controller, because that's what we'll be using mostly. And I will be showing only one part to this. If you don't know Java, if you don't know Spring Boot, don't worry. Only thing which I do into this is I expose this, I expose some REST endpoints. So one of the REST point which I'm exposing is the get REST endpoint. And if you see, if you pass, focus on this path tips, if you say localhost, if you say host colon port and /tips, then I return something. So this is a JSON I return. So tips DB URL is default host I am passing. If you don't set it up anything, then this is a variable name which has default host value. So it's a tips colon default host colon first tip. That's all you get. And we'll see that right now also. How does that work? There are other methods also. I will cover those methods as we go along in the Kubernetes. I will be using these methods in the Kubernetes as well. But for timing, this is what we'll do. Now let me go back to the code, and I understand it might be too much for you, so don't get overwhelmed. I will just revise and summarize it towards the end. So before I do that, let me start my Docker thing on my local. So as I said, I have used Docker machine. So let me see the status of Docker machine. Again, I'm iterating. If you have used Docker desktop, you don't have to worry about it. In Docker desktop, you will get an icon here, Docker desktop icon. Click on that. It will say Docker running and Kubernetes running. If it is running, you don't have to do any of these things which I am doing, because Docker desktop will take care of you, take care of Docker and Kubernetes for you. What I'm going to do is I'm going to do Docker machine.start. So I'm starting the Docker. I will not be starting Kubernetes now. I'll be starting only the Docker machine here. And once it starts, it will give you certain couple of more commands to run, which I'll be running. And then after that, I'll be creating the Docker image using the dockerFile, which I just showed you. So because this is Docker session, I will not be using Kubernetes, but when we reach the subsequent session in the second or third session, Minikube is the one which I will be using using as a Kubernetes engine. So it has started a Docker machine. And if I run this, it is telling me to run this command. So I run this command also. Once I run this command, it's telling me to run this command. It is telling me to run this command. So I will run this command as well. So now if I go here, if I go here now and I say Docker image ls, so you can see these are the images which I have on my local laptop. This is what we just saw. And this is what I built, and we'll build this again right now. But if you go to another terminal and you say Docker image ls, oh, I had already run this command. Okay, let me open another terminal. So if I open this terminal and I say Docker image ls, it won't run. It says this is a problem. So for this problem to go away, and Docker is already running, so only thing I need to do is I need to copy this command and run this here. Now I say Docker ls. Now I can see all the images. Now that's about the Docker setup and seeing the Docker image. I will go through a couple of more commands in sequence, and so I think this have gone through this. So you can clone this application from this. Send me your GitHub ID if you don't have access to this. It's a private repository. I'll give you the access. So we have gone through this, and you will see the same thing in the Docker file there, which I showed you. This is a Docker file. This is the Docker file, and you can have docker ignore file also. It helps Docker, ignore these directories when searching for file provided in. For example, when it's a copy everything from my current folder to the some folder in container. So if I have some folder inside Docker file, it will ignore, for example, target folder or something which I don't want to copy. So I can put that under Docker ignore file. What we are going to do now is, you have seen the Docker file. We are going to build this now. So this is the command I'm going to run: docker build -f tag, then the name of the image, and dot. I'm telling dot means current directory. This is the directory where my Docker file is, because Docker build needs Docker file to build it. So what I'm going to do is, now you see here, you can always see Docker images also, Docker image ls, both commands I'm fine. You see I created this 4 weeks ago. So now I'm going to do is, I'm going to go to my code, cd where my this application is there. So I'm going to go there, _java. Now I'm going to run the docker build command. So docker build, then -f tag, then here java this name can be anything. I have given java -docker _skh, and then dot, where my Docker file is. I run this. Oh, I did not give 2 hyphens. So now it's building the Docker file. So it's using the cache, because I hadn't built it again. So it sees successfully tagged this file. Now if I go here and run this command again, it still says, let me see, there's no change, so it's not reflecting that. So I can always say docker build, and I say -no cache. So it will not use cache. So it will build everything from scratch again. So remember, in my Docker file, I have given cat commands and everything. So this is a cat command I wanted to see, because it's not from cache anymore. So it's printing it's getting this Java file here. So and it's building everything again, because remember, in the Docker file I have mentioned this MVN dependency go offline, so it will download all the dependencies. So this is what it is trying to do now. And after it is downloaded, it will create an image and everything. So then we will be able to see that image, new image got created here. I have not, so going back to this, I have not given colon some version number, but you could always give that colon version number. And this we saw Docker images, you can see. We'll try to run this with some new version also. We'll try to run this command also, and we can see this new version appearing here in the Docker images. And then we'll I will run the container using this image on my local. Remember, I have created the image on my local. I have not published this image to any repository yet. It's all on local. So we'll create this image and we'll run this container. And in the next session, we'll see how to deal with this container. There are various container commands. We'll be running many of those container commands. We'll be testing this application also to make sure it's running fine. I'm able to access the endpoint and everything. We'll be doing that as well. Then in the next session, we'll see how to publish this image into the Docker repository also, hub.docker.com. We'll see that as well. So if you have an account there, good. If not, then create a free account on hub.docker.com. So I think I will pause it here for time being. It will take some time to build, because a lot of dependencies. It will download. It will take 3-4 minutes. So so let me pause this recording. So what I'm going to do now is I'm going to create a Docker image with this particular tag. So let's see. No, I don't want to tag it. I want to build the image using this. So I'm tagging the latest with version. So that also is one possibility. So you can always say Docker build this, and you can give this, or you can, whatever has been here. What I'm trying to do is, there's a latest tag, and you saw the latest tag here also. This is the latest tag for this image. Let's try this anyway. So I am changing the latest tag to version 100. So what I'm going to do is I'm going to set this. So now I will say Docker images again. And you can see I have the another 100 tag. I have the latest one also. I have, but I tag this as 100 also. Now, if I don't want to use 100 or I don't want to use any of these, I can always delete it. So this is a command docker rmi. So here I'm giving the image name, which is this, and let me put this underscore skh and the version. Sorry, syntax error. So now if I see this, so now 1.00 is not there anymore because I just deleted it and I have the latest one only. So that's one. Now let's try to do one more thing. Let's see if this works or not. Let's take this. What I'm going to do now is, so I will try to build this and I say docker images, and you see 2.00 is also there, and docker images, docker image, ls, both are the same commands. I see latest is there, 2.00 is there. I want to delete 2.00, so I can always do that. Now 2.00 is gone, so I have the latest one. So with this I conclude today's session. Let me pause the recording.